Good morning, viewers. This is Kasturi Day. Today, I've again come with the question answers of chemical change and reaction chapter. So I'll continue with those question answer discussions. So before I start, I will request you to please subscribe my channel so that you can get the notification of my next video. And if you're liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to meditate before you start your day, you're studying. Okay. So before that, I would like all of you to join this meditation section. This is a 1 minute section I'm practicing in every video for my last few videos. So please meditate for just 1 minute and then we'll start the discussion. Okay. So please concentrate on a dot, on a point of light. Okay. And think to be that an energy which you get from your God, which you believe, okay, which gives you energy for the whole day, give you positive energy that will increase your concentration, as well as that will increase your positivity, increase your memory power, and you will happily spend the day. Okay, so please meditate for just 1 minute. Okay, so let's start with the discussion for today. So first question we will discuss today is give reason for the following. Silver nitrate solution is kept in a colored bottles. Why silver nitrate solutions are kept in colored bottles? Because what happens when it receives light, when silver nitrate receives light, it will decompose to form the silver. So to avoid that decomposition of silver nitrate, we keep the bottles in, we keep the silver nitrate in colored bottles. Okay, from where from the colored bottles, the sunlight will not enter, proper sunlight will not enter the bottle, and that will not reach the silver nitrate to decompose it to silver metal. Okay, then why molybdenum is used in the manufacture of ammonia? See, molybdenum is a promoter. It enhances the efficiency of the catalyst of iron. Okay, it enhances the efficiency of the catalyst, which is used in the reaction. In the process of ammonia manufacture, and in the manufacture of ammonia, iron is used as a catalyst, and it enhances that efficiency of that iron catalyst. Okay, that's why molybdenum is used. It is a substance which is used to increase the efficiency of a catalyst. That substance is known as a promoter. So molybdenum is a promoter. Then blue solution of copper sulfate changes to green when a piece of iron is added to the solution. Okay, so blue solution of copper sulfate, copper sulfate is blue in color, we know. Okay, so that solution, copper sulfate solution, is blue in color, and that will change into green. Why? When a piece of iron is added to the solution. Why? Because when iron is added to the blue copper sulfate solution, that reaction takes place between the two, and iron will displace copper from copper sulfate, and itself will combine with the sulfate radical to form iron 2 sulfate, which is green in color. That's why the color changes from blue to green, due to the formation of iron 2 sulfate, and copper will be separated from it. Okay, and copper, we will see that on the iron deposit, on the iron nail, there will be copper deposits, reddish brown deposits on the iron nail, that will be of copper. So copper will be separated from copper sulfate and the solution will become from blue to green. Okay. Then colorless concentrated sulfuric acid in a test tube changes to blue in color on adding a piece of copper to it. Okay, we take a test tube in which we take a colorless concentrated sulfuric acid. Okay, concentrated sulfuric acid we take, though it is slightly yellowish tinge in color, but say it's colorless. Okay, so that change, that color will change to green in color. Okay, it's like not green because it will, as it is yellow, so the blue, it will change into blue. I mean, slightly there is copper sulfate, sulfuric acid is slightly yellow tinge is there. So we can see that it will be not changes to blue or green, like it will be blue in color, okay, on adding a piece of copper to it. Because when copper is added to the sulfuric acid, copper will react with sulfuric acid and hydrogen will, copper will displace hydrogen. Sorry, I'm sorry. Hydrogen will be displaced from copper sulfate. Sulfuric acid, and copper sulfate will be formed. And the copper sulfate will be blue in color, not green, it's blue in color. Okay, so the colorless solution of sulfuric acid will change into blue because of the formation of copper sulfate when sulfuric acid is, when copper is added to sulfuric acid. Okay, copper is added to sulfuric acid. The colorless sulfuric acid, the colorless solution of sulfuric acid will change into blue in color, blue or color of copper sulfate solution. Okay, copper sulfate solution will be formed and hydrogen will be displaced. Okay. Then what happens when ammonium nitrate is dissolved in water? It becomes cold. Why? When we take a beaker and ammonium nitrate is there inside it and we add water and it dissolve it, we will see that the beaker will become cold. Why? Because it is an endothermic reaction. When there is ammonium nitrate, when dissolves in water, that is a endothermic reaction. That is, it absorbs energy, it absorbs heat from the surroundings. In the form of heat, it absorbs the energy in the form of heat from the surroundings. So when it absorbs heat from the surroundings, it also absorbs the heat from the beaker. Okay, when it is absorbing the heat, when the compound is absorbing the heat, it will make the beaker cold. Okay, that's why we feel that the beaker will become cold, surroundings will become cold as it is an endothermic reaction. Then milk sours in hot, humid weather. Why? In hot, humid weather, what happens? Milk forms lactic acid and it curdles and it becomes sour. In hot, humid climate, what happens? Due to the heat, milk will turn into lactic acid. Okay, it will form lactic acid and it will curdle. That is, water will separate from it and the casein will it will form curdle. So at that time, the milk will become sour. The sweetness of the milk will disappear. That is, a new substance, totally new substance will be formed. And you will not be able to reverse back the curdle into the original milk. Then anhydrous copper sulfate turns blue when water is added to it. See, anhydrous copper sulfate is white in color, it's powder in form. Okay. When we add some water to it, it will absorb that moisture and it will form hydrated copper sulfate crystals, which is blue in color. What is hydrated copper sulfate crystals? It is the copper sulfate which has some water molecules in it, that is 5H2O. Okay, each CuSO4 will contain 5H2O, that is hydrated copper sulfate, that is called, and that will form crystals which are blue in color. That's why it turns blue when anhydrous copper sulfate, water is added to anhydrous copper sulfate. Then zinc oxide turns yellow on heating. What happens? Actually, zinc oxide is white in color, but On heating, it turns yellow as it loses its oxygen reversibly at high temperatures. So when the temperature rises, when the zinc oxide is heated, it is originally white in color, okay? And when it is heated at temperature, the temperature rises, and at that high temperature, the zinc oxide loses oxygen. It will give off its oxygen, and what happens? It will turn to yellow metal, zinc, okay? And what happens? This will reversible. That means if you add the oxygen, again, it will come back to its zinc oxide state. So it's a reversible reaction. Then silver wires become black in air. Why? Silver wires become black in air. As silver reacts, what happens? There is H2S gas present in the air. We have seen that silver utensils, if we keep for outside for some time, for some days, for some months, it will turn into black in color. Why? This is because the reason I'm talking about, okay, we are discussing now. So what happens? There in the air, there is hydrogen sulfide gas, H2S gas, which is present in the air. Now the silver wire or the silver utensil that reacts with this H2S gas, and it forms black colored silver 2 sulfide. Okay, black colored silver 2 sulfide. This, or rather you can say it in this way, that it forms silver 2 sulfide, which is black in color. That's why it turns black. Okay. Now, after whitewashing the walls, a shiny white flush on the walls is obtained after 2 or 3 days. So we have seen many times that when we do a whitewash on our walls, on our house walls, we have seen that a shiny white flush will come out after 2-3 days after whitewashing. After 2-3 days, we will see there is a shiny white light flushing out. Why? Because the whitewash on the walls that contains calcium hydroxide. Okay, that contains what? Calcium hydroxide. And that calcium hydroxide reacts with the carbon dioxide which is present in the air. Okay, that calcium hydroxide reacts with the carbon dioxide which is present in the air, continuously gets reacted for 2-3 days, and it will form what? Calcium carbonate, which has a shiny white finish. Okay, so we can see a shiny white finish after 2-3 days, because that time it takes to react. This calcium hydroxide takes that time to react with the carbon dioxide of the air to form that calcium carbonate. Okay, next is this chemical reaction becomes faster at high temperatures. Why do we see that a chemical reaction becomes faster at high temperatures? Because at high temperatures, the movements of the particles are greater. Okay, the particles of the elements or compounds which are present, which are reacting, okay, the reactant particles, they start moving very faster. So when the temperature rises, the particles move faster and the reaction takes place much, they move faster at high temperatures, and the reaction takes place also become fast. Okay. Then to dilute sulfuric acid, why do we add acid? When we take sulfuric acid or any acid, we add generally acid to water and not water to acid. You must have seen many times in our household also, we don't add water to acid. We always add some acid to water. Why this happens? Because what happens, as the mixing of water to an acid is highly exothermic in nature. when we mix acid with water, a very high energy, or rather by high amount of heat is liberated. Okay. Now, if we add water to acid, it produces a very large amount of heat, which can break the container, and sometimes it can cause burning. Okay, and this container can, can be thrown out anywhere. So very explosive type of reaction takes place as large amount of heat is evolved when when water is added to an acid. So what happens? We always add acid to water and not water to acid to avoid this exothermic explosive nature. Now, sodium metal is stored under kerosene. Why? We know that sodium comes in the metal series, metal activity series, in the second position below potassium. So potassium and sodium, they are very highly reactive metals. Okay, they are highly reactive metals. So what happens, as they are very reactive, so what do? We keep that sodium or potassium in the kerosene to prevent it from coming in contact with the oxygen and moisture of the air, so that it does not come in contact with the oxygen or moisture of the air. And if this happens, then it will react with the moisture which is present in the air, and the sodium hydroxide will be produced, which will produce a lot of heat. And this is also an highly exothermic reaction, and it can produce an explosion. So that's why, to avoid this explosion, to avoid this extreme lot of heat production, we keep that sodium in under kerosene. Okay. Now, when iron is exposed to air, it corrodes. We have seen lots of times that when iron is kept outside in the air, it will corrode. It will be some brown colored substances formed. What is that? That is rust. Okay, and that will corrode the iron, eat away the iron. Okay, so that is corrosion. So when iron is exposed to air for a long time, it reacts with the moisture of the air. The air contains moisture, we know. So that moisture is taken by the iron, and it will react with that moisture to form a brown, flaky substance that is known as rust. And what is that? That is the hydrated iron oxide. Okay, the dust is hydrated iron oxide, that is Fe2O3 and 32H2O. That may vary, but it is almost the same. Okay, so this corrodes the iron. Okay, this hydrated iron oxide, that is rust, and that will corrode the iron. Then a reducing agent is a substance which loses electrons. Why we say that a reducing agent is a substance that which loses electrons? It is a substance that oxidizes itself. A reducing agent is a substance which can oxidize itself but reduces others. Reducing agent, so it will reduce other, but itself it gets oxidized. How it is done? When to reduce others, it will give them electrons. To reduce others, it will donate electrons. So when it is donating electrons, then it will lose electrons. So that's why a reducing agent is a substance that will lose electrons. Okay. Now, in a reaction of copper with oxygen, copper serves as a reducing agent. Now, as reducing agent lose electrons, also gains oxygen to oxidize itself, but reduces others. So copper gives electrons to oxygen, and it will oxidize itself. As it is giving electrons to other, copper is giving electrons to some other atom, some other element, then it will what? It will oxidize itself. So copper oxidizes itself by giving electrons to oxygen, and gains, this oxygen will gain gains O2 to oxidize itself, but reduces oxygen. Oxygen will be reduced because it is gaining electrons. Okay, copper is giving electrons, oxygen is gaining electrons. So as copper is giving donating electrons, that it will oxidize itself, and as oxygen is gaining electrons, so it will reduce itself. So it serves as a reducing agent. Copper serves as a reducing agent. Then iron 2, that is ferric oxide, Fe2O3, will react with aluminium to form aluminium oxide, and iron is displaced. This reaction is a displacement reaction. Why? Because a highly reactive element like aluminium, in this reaction we can find that aluminium is a highly reactive element than iron, and it will displace iron from Fe2O3. Okay. Then photosynthesis is considered as an endothermic reaction. Why? Because in this photosynthesis reaction, what happens? Sunlight is absorbed by the green plants. So what is sunlight? Sunlight is a heat. Okay, it's an energy rather. It is an energy which is absorbed by the plants, by the green plants. So as green plants are absorbing energy, so it's an endothermic reaction. Okay. Next, we are coming to some true and false. So during endothermic reaction, heat is liberated. That's false. We know during endothermic reaction, heat is absorbed. During chemical reaction, always a new product is formed. That's true, because chemical reaction means there is a chemical change. Okay. And what happens? A reaction is taking place, and a altogether new product will be formed, which will be different from its parent products, parent reactants. Then ranacidification of butter is a chemical change. What is ranacidification? Ranacidification is a process by which butter will turn sour type. There is a chemical change taking place. Why? What is a chemical change here? It is taking place by this process. The lactose and sugar which is present in the butter, that will change into lactic acid. And I told you, when milk is turning sour, that time also the lactose which is present in the milk, that will change into lactic acid. Okay, so here also in the butter also, the lactose and sugar that is present in the butter, that will be changed into lactic acid by bacteria which is present in the presence of oxygen. Okay, in the presence of oxygen in the air, that will change, that will assist the bacteria to change the lactose and sugar of the butter to change into lactic acid. And this lactic acid is completely a new substance which is formed, and that will not be able to, that will not be reversed into the original butter state. So that's a chemical change. Then sodium nitrate is stable towards heat. That's false. Sodium nitrate, when it is heated, it will decompose into sodium nitrite, and oxygen will be liberated. Then neutralization is a type of double decomposition reaction. See, neutralization, that's true, because in this two compounds, that is, one is base and acid. Neutralization, what happens? A base reacts with an acid to form salt and water. We know that. That's a neutralization process. That's why we call neutralization, as water is formed. So when base reacts with acid, their radicals are interchanged. Okay, the positive and the negative radicals of a base and positive and a negative radical of the acid, that are interchanged. So their radicals are interchanged, and therefore that is a double decomposition reaction. Okay. Next is formation of manure from the leaves is a chemical change. That's true, because what happens when a manure is formed from the leaves, the manure is a very different substance, a new substance rather, from that of the parent leaves. Okay, that's why it's a chemical change. Then iron pipes which are coated with zinc, they do not get rusted easily. That's also true. Why? Because the iron pipes which are coated with the zinc, that protects the iron which is lying inside the coating from reacting with the oxygen and moisture which are present in the atmosphere. So that's why they do not get rusted. Okay. Then we come to state which of the following are oxidized and reduced. Then Cu gets Cu to Cu2 plus. Okay. See, this is an oxidation reaction. What happens? Cu gives to Cu2 plus. Cu turns to Cu2 plus. It is copper becoming copper 2 plus ions. So that means it will lose 2 electrons. It will lose 2 electrons to become Cu2 plus ions. Okay, I have written here plus. So you can, if you write this plus, change this side, you change the side of these 2 electrons, it will become minus here. If you write in this way on the left hand side. Okay, so what happens? It will lose 2 electrons and it will become 2 plus. As it is losing electrons, so it's an oxidation process. Then oxygen 2 minus will become O2. Okay, so it will, what happens here? It will, this is also an oxidation process, because 2 minus means it has 2 extra electrons. If it is losing to that extra electrons, it will become the original oxidations or oxygen. So it will lose 4 electrons here to become O2. Then chlorine will become Cl minus, whereas it is Cl minus, that means 1 extra electron is added there. So to become extra electron, it will gain 2 electrons from other chlorine atom or any other, to gain 2 electrons to become 2Cl minus. Fe becomes Fe2 plus. That means it loses 2 electrons. That's an oxidation state. Okay. Then S will become 2 minus. See here, 2 electrons are, it will gain 2 electrons. That means it is a reduction process. When Fe2 plus to Fe minus, that means Fe's rather. So it here also it will gain 2 electrons to become zero state. Okay, so that's a, when it is gaining electrons, it's a reduction. Then Fe3 plus to Fe2 plus, that means it is gaining 1 electron and it becomes a reduction process. O2 minus to O, that means it will losing 2 electrons to, that is an oxidation state. Chromium 7 plus to chromium 5 plus, it will gain 2 electrons to, there is a reduction process. Then zinc will become zinc 2 plus, that means it is losing 2 electrons, so it's an oxidation process. Now we come to some short and long answers, questions answers. Okay, what would happen on burning if the proportion of nitrogen and oxygen in the air were reversed? Okay, so what happens? Actually, in the air, the ratio of nitrogen oxygen is 4:1. That is, nitrogen is 4 and oxygen is 1. So nitrogen is to oxygen is 4:1. And if in the atmosphere, by any chance, this proportion is of the air is reversed, that is N2:O2 becomes 1:4, that is oxygen becomes more than nitrogen. Here, actually what happens? Nitrogen is more than oxygen. Okay, but if oxygen becomes more, what happens? Oxygen is very reactive, non-metallic element. Okay, and if this proportion reverses, that is oxygen becomes more in the atmosphere, then what happens? It will become explosive and oxygen will react with the nitrogen to form a poisonous nitrous oxide. Okay, burn everything. Oxygen becomes more, that means everything will start burning, highly reactive. And it will also combine with nitrogen to form a poisonous nitrous oxide. Now state whether the following changes are physical or chemical. Acidification of butter, that's a chemical change. I told you. Souring of milk, that is also a chemical change, because totally new substance will be formed. The curdling of the milk, that is new substance. Curdle of the milk, that is a new substance. Then tearing of paper, if you tear the paper into bits, smallest bits, that will still exist, that will still have the properties of the paper. So that's a physical change. Then stitching of the shirt. If you stitch the shirt, also that shirt will remain the shirt. Even the thread that is attached with it, that will also contain the properties of the thread only. Okay, so that's a physical change. Justify the following statements. Passing hydrogen to boiling sulfur will lead to a chemical change. When we pass hydrogen to boiling sulfur, what will happen? When we pass this hydrogen to boiling sulfur, a pungent smell will be produced due to the formation of H2S gas. Rather, it will foul smell, rather not pungent, it will be a foul smell of rotten eggs. that is of H2S gas. Okay, so and that gas has a completely different characteristic than the hydrogen and sulfur. So that is a chemical change is formed. Then, and it will not easily be reversible to hydrogen and sulfur. Then electrolysis is a chemical change. Why? Because a chemical reaction is a process in which involves a rearrangement of the molecules or the ionic structure of the substances. We know that a chemical reaction and a chemical change where there is involvement of the rearrangement of the molecules or the ionic structures. Okay. So when electrolysis is done, it is found that the cations and the anions of the strong electrolyte, they migrate to the cathodes and anodes of the electrolytic cell due to the passing of electricity. When electricity is passed through, electrolysis is being done. At that time, what happens? There are cations and anions. Okay, the cations and anions will be attracted. They will be attracted by the cathode and the anode. Okay, and so this is this electrolysis process is a chemical change. Okay, so I'll stop here. I'll continue with the rest of the question answers which are left in my next video. Please go through this. If you have any doubt regarding this chapter, this question answers, or you want to know some other questions, you want to clarify some other answers in this regarding this chapter, you can please write in the comment box. If you are liking the video, press the like button, share with your friends. And also if you are new viewer to my channel, so please do subscribe to get the notification of my next video. And if you are existing viewer, so please, you also please do observe these videos, do comment. And if you are if you want to give any tests regarding these, any of the chapters, what I have taught till now, so you can give me a comment and I will arrange for that test. Okay. And don't forget to meditate before doing your, starting your day. Okay. So thank you for watching and have a good day.